Testing, testing. I think we should be live. And then give it a minute for some people to roll in before I kind of go over some details here, what we're going to talk about today. But hopefully there's some returning people from book club, so you probably know what it's about. And this month's book was Reinforcement Learning for Finance. Every month we've been reading a new book around AI. It's kind of why we call it AI Book Club. And yeah, it's been really fun. So again, I'll wait for some people to join in, say hello in the comments, and I'll share a link if people want to join in this stream later as well. Some people like to come up and talk here. You don't have to turn on your camera if you want to just join with audio as well. But I know since we switch formats, a lot of people just like talking in the chat, and that's totally fine as well. I say hello myself real quick in there. And actually, probably, I think most people are tuning in on LinkedIn. So let me just open that stream up on my end real quick. Make sure we're live there as well. I know sometimes there's a little bit of a lag from when I talk to when everyone else sees it. And there's quite a few people RCP'd. So we'll see how many people show up. Again, I'd give it a minute here before we go into some of the details. But if you're joining in, again, say hello in the chat, and I'll also share a link here shortly if you want to join in the stream. But I'm going to do a little bit of the setup first, and then we'll go into that. And someone said, any fellow traders in the group? Welcome, Cody. That's cool. I'm actually not a, I'm not a trader. And so I thought this was really interesting because I've been interested in like what that industry looks like. And so I'd love to like connect with you if we're not already connected and kind of see what you're doing. It always seems like a really interesting area for machine learning and one that I wasn't super familiar with. So this book was kind of a good kind of, maybe a simple introduction to it. I think the real world applications are really complex. And this book did a good job of kind of getting you going with it and thinking about the problems. But I think like the environment and stuff that you set up in the book for trading is probably an oversimplification than what the actual industry is like. So I'd love to, I'll connect with you after and get or follow you because I want to see if you share cool stuff around it in the industry. I'd love to see it. So with that, I'll go through some of the slides. Again, I know people are probably going to be rolling in here. And this slides just kind of help us keep pace with some of the chapters. And I took some notes on some of the chapters so we can discuss them. I'll also share the link to the book. So this is an O'Reilly book. You should be able to find this book pretty much anywhere. I usually read it on the O'Reilly platform, but you can also find it on Amazon and libraries. And actually most libraries and a lot of universities have a partnership with O'Reilly where you can actually get the online platform for free, usually with like one of their cards. So keep that in mind as well. And so quick notes about the book club. So again, in short, we read a new book every month and discuss online. Also, hopefully my audio is okay today. Usually I'm at home. I have a little bit of a studio setup, but I'm in an office today. So hopefully it's coming through okay. And we also have a Slack channel, part of the open source flight community is kind of where there's an AI reading club. So if you do want to discuss the book after this meetup live or the next book, which I'll talk about the next ones we're going to read, you can join the Slack channel and do that there as well. And then also I have been keeping track of the books that we're reading and posted the next books in this GitHub. And then one last link here is you've probably found this either on like Meetup or Luma or LinkedIn. If you want to attend other future AI book clubs or other kind of meetings like this in general for the community, I recommend joining Luma. I think I'm going to try to eventually make that kind of the source of truth and push more people to RCP there. It does a good job of like sending out notifications and stuff like that. But anywhere is going to still be good for a while. But eventually, I might push over to more on Luma instead of Meetup. So make sure you join there as well if you're interested in staying in touch with what's going on. So the schedule so far for 2025, we've been reading a book every month. Hopefully, again, some of you have been here in the past. This is kind of what we read so far. January, building LMs for production. February was RAG-driven generative AI. March was AI engineering. April was AI agents in action. May was hands-on APIs for AI and data science. June was a 100-page language model book. And then here's July, reinforcement learning for finance. And then these are the next ones scheduled, but I'd love to hear what you want to read next. So we have December left, which could be maybe a bit of a shorter book. Usually December, a lot of people don't come don't come to events at the end of the month. So usually I try to do like it kind of halfway through December instead of at the end like normal. So we'll maybe look for a shorter book or a simpler book. So if you have ideas, let me know. And then we'll probably go back into this in January again. And we have a whole list of other books that seem interesting coming out soon or early next year. But next month is going to be building agentic AI systems. September is effective conversational AI. I didn't read this yet, but it looks really cool. This is more about thinking about deploying conversational AI as a product. So like if you have a chatbot on a site, how should it actually interact with people, et cetera. I thought it seemed like really good. And then October is LLM Ops. Then November is deep learning for biology. So again, another field that I don't actively work in, but I'm excited to kind of see how to apply machine learning to that field and what that field looks like for a machine learning or deep learning engineer. And then December, we're still deciding. So again, if you have ideas, let me know in the chat. There's a whole bunch of them listed. This one's coming out in October. So we'll probably do it but I didn't put it because sometimes they get delayed. So I want to give it a month in case it gets delayed, or 2 months. So this will probably go in January, just in case we try to do a shorter book in December. And then again, this format for this talk is, again, say hello and talk in the chat. I know a lot of people like to talk there. How to join, you can message me. And actually, I will share a link here in the chat on LinkedIn. If you do want to come up and join the stream here, give me a minute. They changed the UI, how to do this. And again, you don't have to turn on your camera. If you just want to do audio only, that's fine too. And then also if you just want to stay in the chat, that's also fine as well. I've noticed most people like staying in the chat, but there's been usually a lot more engagement than the previous one, so that's pretty good. Although the chat is a little quieter today, so I don't know, if something else is going on, people can't make it, totally get that as well. And also, actually, I was thinking, because we used to be kind of hosted rigorously at 1 p.m. on a Tuesday, because we used to meet weekly for most of 2024 when we kind of chunked out these books into 4 chunks and then met almost every week and talked about it. And it was good to have that consistent time. But now we're doing the longer kind of in between and the monthly format. We could switch up times. So if people have times they think would work better, I'd love to hear about that as well. 1 p.m. I know not a lot of people can make it if they're at work. It's 1 p.m. my time in Pacific time. Obviously, it's like 4 p.m. in the East Coast and different times in different parts of the world. And we had some regulars that were in different parts of the world that couldn't make it if it was too much later. But they haven't been a regular now for a while, so potentially we could change the time if people are interested in that. I might look at that in the future. And so it looks like the next month's one, well, shared the Amazon link for building agentic AI systems. Yeah, and like I mentioned too, it's also in all these except for this one have so far been in the O'Reilly online learning platform. So if you want to look at getting access to that, like I mentioned, most universities and libraries will even have access to it if you have like a library card. Not everyone though, and a lot of the U.S. I guess I don't know about the other countries. So you would look at that. You could look at that too if you like reading online. It's pretty cool to have access to most of these books. All right, and then also because we've had so many regulars, I just always want to include that like you can talk about stuff other than the book in the chat, especially as we kind of start building out the community. So if you want to dive in the book or before we dive into the book, or just as we're talking about the book and after, if you want to put in the chat anything interesting that you're working on, if you're hiring, feel free to shout out your company, share your career page. If you're looking for a job, feel free to let people know in the chat as well. And also you can share any other awesome projects you're working on. This has become a little bit more of a community. Again, chat's a little quieter today, but usually there's been a lot of people that show up, and it's been a really cool kind of community that's growing. So if you want to talk more than just the book, or more than just about the book, share in the chat. And then one thing I was going to mention is let me pull up the link. If you happen to be based in Seattle, I know a fair amount of people that come to this often are. They find out the Seattle meetup I post on. I'm actually hosting a happy hour at the end of August in Seattle. So it'd be cool to meet up with people in real life as well. And we could discuss the book. We can discuss other things about AI, but it'd be kind of cool to, well, it will actually be right after we finish reading the AI agentic systems. So if you want to discuss that book in person, that's also a good place to come and join for that. All right, so I'll go into the book chapters. Like I mentioned, chat is a little quieter today, and that's okay, but feel free to say hello in there. And then also, if it's a little quieter today, I might end up cutting the stream a little short because I have some stuff I have to get back to as well. So just putting that out there. So this is reinforcement learning for finance. These were the chapters, and then I have some notes, like I mentioned, kind of breaking out some of the chapters, but feel free to jump in here either in the chat or join the stream, like I mentioned, if you want to talk more in depth about your experience with these or questions about it. So chapter 1 was learning through interaction. And again, I'll go deeper into these, I think, after I read them out. Chapter 2 is deep Q learning. And then we had financial Q learning. And then chapter 4 was simulated data. And then chapter 5 was generative data. I thought it was actually kind of cool using using a GAN example for generating artificial market data, which was pretty cool. And I see someone said, howdy, welcome, Ram. Like I mentioned, feel free to post in the chat if you have any questions or any comments about kind of the chapters that we were reading this month. And then chapter 6 was algorithmic trading, 7 was dynamic hedging, and then 8 was dynamic asset allocation, and then 9 was optimal execution, and then 10 was super short, just some concluding remarks kind of in the book. So I'll go through, I have some notes from the chapters. They're not super extensive here. Go check out the book. And I think I shared the link as well to the GitHub. I'll actually do that again though. Oh, did I have their GitHub? Yeah, I do have their GitHub. So most of the books too are, have a GitHub repository that you can go check out. So actually all the code to the book is in here and you can check that out without kind of the extra stuff. But I think I would recommend reading the book and having it explain kind of what's going on in the code. So chapter 1 was learning through interaction. Starts out with Bayesian learning and Bayes theorems, basically how to kind of revise your belief or kind of probability about a hypothesis after observing some evidence. And they use the example of flipping a biased coin or a biased dice. And then you might say, think the coin's going to be 50-50, but then after a certain amount of flips, you say, oh, it's actually 60% sure it's going to be on heads. And you keep observing the outcome and then basically update what you think the probability for the next outcome is going to be. And that kind of leads into reinforcement learning. Reinforcement learning kind of builds off the coin flip example where you have a reward in an environment and then you learn through interaction. So these steps could be a lot different than just flipping a coin. Like a good example, I think people have seen or thought about how in AI, or actually if you've ever played chess yourself, you kind of are looking at an environment, which is like the chessboard, and then you make your checkers move or chess move, and then you kind of get a reward of that being a good move or a punishment of like someone taking it and it's not a good move. And actually going back to the chess move piece, there's actually deep Q learning. So you have reinforcement learning where you basically you have a state, which again could be something like a chessboard, and then you make a move and you get a reward or punishment on it. But that on itself, just the reinforcement learning piece with I think just Q learning is often what it is without deep Q learning. It struggles or doesn't do a good job of planning out what's kind of coming next. So you want to be able to make a move, but also plot, okay, I do this move, and then someone does another move, you have to think ahead. And this is also true with markets, right? Like you can make a trade, but you want this trade to do good over months or days or years or something like that, not just a quick payoff. So it gets really hard. You have to think about the future, not just the current state and how something did. And that's where deep Q learning comes in. So you evaluate both the immediate reward of like, was that a good immediate move? And then also the delayed reward. And so that's like again, is 5 moves later, was that probably a good one? And so chess and Go, if anyone's played Go or watched the documentary AlphaGo, which I would totally recommend. Really interesting. Basically, they're using reinforcement learning and different types of deep Q learning. That's where DeepMind came from, Google DeepMind, which is doing a lot of the cool stuff with Gemini and LLMs now. Originally, they were their own separate company, and they're really good at reinforcement learning, building AI to play games, and they had it play Go, which is a really, really complex game if you've never played it before, and basically thinking about these immediate states and then the delayed reward. So it gets long-term payoffs and trades, of trades is kind of how I mentioned it, ties into the reinforcement learning for finance piece specifically. Anyway, deep Q learning is the next chapter, which dives deeper into it. I think I kind of already summarized what it was. They break it down first as decision problems. So you optimize for decisions in action spaces where you have a really complex thing, but you can break it into smaller pieces and have algorithms do good at those small pieces and then build that into a larger system. And that's where dynamic programming comes into as well. So you're breaking into smaller pieces. And then you have the deep Q learning that can help approximate and scale the dynamic programming. Talk about Q learning, which is kind of I think they put it as like model-free reinforcement learning. And they use the cart pull example. So that if you haven't seen that before, it's kind of the classic little reinforcement thing you've probably seen if you've looked at this before in the past, where you have like a cart and a pull and you have to balance the pull. And you basically do that by making a move in your environment and getting a reward state of that pull being balanced. So actually a little code example to run that. And then it goes deeper into Q learning versus just supervised learning. And this was kind of an analogy that I don't think exactly was in the book, but I kind of pulled this together where, and this might not be exactly correct, but I think kind of how it works is like, supervised learning is you're usually looking at the features and then the target. And so you're kind of given the key of like what the answer to those features are. And so I put this analogy of like, it's kind of like a student with a answer key. You study from examples where the correct answers are given, and you start learning those features that make it up. And in Q learning, you're basically learning to play a game without those instructions. You try all the different experiments inside the environment, and then you get rewards or punishments, and you learn over time what works best. So usually you're not just looking at the data set a few times or anything like that. You actually play an environment quite a few times and then get those rewards and then kind of build up what you think is going to be good actions in those spaces. And then in financial Q learning, this chapter, they talk about the finance environment. So like I mentioned, I think they kind of build a fairly basic environment here. Obviously, you can only cover so much in kind of this type of book versus working in real life. So I'm sure the market environment, like Cody, I think was a trader, it sounded like. I'm guessing that the finance environment, if you work in that area, is way, way more complex than the one in the book. But basically, you build a simulated market with about, I think they have like 10 stocks. And they mention you need to interact with that environment a lot to learn. And basically, in this case, it's historical market prices. They kind of have this environment inspired by games or a game environment. So if you've looked at reinforcement learning in the past, a lot of the stuff was in game environments because it works really, really good for getting actions and then rewards, having that kind of space built out. A big problem with the finance environment, especially with just historical market prices, is their static historical financial time series data. And it doesn't really take into account a lot of other like current events, or actually even sometimes if you're making big trades with your agent, that can affect the market. So it doesn't bring that into account, which can be a big problem. So basically, you have the static thing, and it can work good for kind of training a basic agent, but there's a lot of problems kind of with it. So I assume in the real world, they added noise in another chapter here, but also just in the real world, you're collecting probably so much current data or more recent data to have a model run on, even though you might not be making actual trades if you don't trust it to make money yet. They talk about the deep Q learning agent, basically just taking actions in those environments. Also, yeah, it's interesting because agents is the word that was used all the time in reinforcement learning. Now it's used all the time with like LLMs and building applications there. It's kind of fun seeing that, but it comes from the same thing of you being able to take action in some sort of space where agents with LLMs are usually, they have agency over actions like calling different tools or running certain functions or something like that. Oh yeah, so I mentioned that I have limited data in the example, or in the simple environment, the next state doesn't matter on what the agent did. So that's a big thing, is like you take an action in that environment, but it's always going to be static basically in this case. So that can be a big problem. Kind of just a hard thing when using historical data. So then the next chapter goes into helping a little bit with this, creating simulated data with data augmentation, basically being able to add noise and create more variation into your time series data. And then let's see, catching up on my notes here. I found out, because I read this book actually more early on than I normally do in a month, because I had vacation and I read a lot of it during vacation. And then I realized it's kind of a mistake, because then a couple weeks go by and it's not as fresh in my head. So I did try to recap it, but I'm noting for myself next time, even if I have free time, it's actually almost a little bit better, I feel like, to read it in like the 2 weeks leading up to discussion. For me, works kind of best. Obviously, you can read at your own pace. But I'm catching up on my notes again. Oh yeah, so they add in some data around like training a model to predict market crashes with indicators. That can be a big deal too. Like that's really hard to do, especially with just some historical data. Like you don't know what's coming next. You want to increase the size and diversity of your data. Like I mentioned, it's kind of small in the last one, and it might not be as diverse as you want it to be. And basically just helps improve the model and make it a little bit more robust. And this is true with data augmentation in kind of most senses, like computer vision and any other places. Basically, you're adding variations, like in computer vision, which is what I've done a lot of work in, not reinforcement learning with finance. You're adding augmentation to images, like making them darker or turning them slightly, or adding some noise to the image, and that makes your model more robust on doing classification or object detection or whatever it is that you're training it to do. And then generated data, you can also see my notes get a little bit more sparse further as we go. Generated data, this is the chapter that actually has some cool stuff talking about GANs to create new market data. I thought that was actually pretty interesting. I don't think I had seen a GAN used in an example. If you haven't used a GAN before, it's what does it stand for? Generative, is it? No, now I'm thinking of RAG, the acronyms. It is generative something. Why am I blanking on what the A stands for? Basically, it's a computer vision algorithm that generates pixels before diffusion models. Diffusion models are kind of now the hot ones that most of the LMs use to create images. But GANs were used a lot, and I actually did some work with them several years ago. They were pretty interesting, but basically you can create an image, so you could take like market data and then have it actually create a new graph with different variations. And there's a lot of cool stuff you can do with like music with it as well. So actually used in some time series generation, which is pretty interesting. Oh, generative adversarial network. My brain remembered. Oh, and I see several people in the chat said adversarial now. Yeah, generative adversarial network is what it stood for, or what it stands for. And then chapter 6 is algorithmic trading, prediction. We went through prediction, game revised. We created, I think, a little bit more of a robust trading environment here with the stuff that was in the other chapters. Created a trading agent that could interact with that new finance environment. And then you kind of separate out the deep Q learning into an agent class, and then have it run in the simulated environment. And then you use the deep Q learning to trade, basically looking at the market rise and fall in this case. Again, it goes a little more simplified than what you would probably do in the real world. But again, this is kind of an interesting start to thinking about it. Like I feel like I learned some new stuff in the reinforcement learning, but also thinking about how it would apply to finance in general. But I guess it doesn't go quite as deep into reinforcement learning as, not necessarily that I wanted from this book, but that I feel like I should go into if I want to do more with RL. And in the state space, it can include a lot more features. So I think in this one, again, like I was saying, pretty simplified, but you might have a lot of features like your price and volume, which I think was in this environment. And that's kind of when we talked about the deep Q learning earlier in the slides, where if you have the immediate action and you want a reward from that, but then you want to see over time how it did. You can both use the features, and then they have lags, which is kind of the past values as inputs. And then you can discover complex insights too, like using deep learning and reinforcement learning. If you have a ton of different features, one cool thing about the deep neural networks you can add to the Q-learning is that you can take in a lot more inputs. Just again, like with computer vision, I often draw from that because, like I said, I've worked in that a lot. But if you have a neural network, it can look at a ton more pixels individually, more carefully than like a human could. So you can have RL reinforcement learning algorithms sometimes discover more complex insights than you might be able to draw up as a human, which is pretty cool. And then you also want to just experiment with different features and lag strategies. And then 7 was dynamic hedging. And this one it talked about delta hedging, hedging environments, hedging agent, and then BSM, I think stands for, I forget what the M stands for. I think it was like Black Skull something. Oh yeah, put a note of Black Skull. I forget what the M is. But basically, this is a hedging formula, I guess, that some people have used in the financial world. Basically, you want to reduce your risks. So dynamic means continuously adjusting, like buying and selling your stocks. And you can learn directly from the market data pricing model without some bias variables that I think they used in more traditional formulas, like delta gamma. I think that's what they were saying in the book. And again, try DQL, deep Q learning, on a whole bunch of these different strategies. And then chapter 8 was dynamic asset allocation. So the example they give is like 2-fund separation. A lot of people, you might see this if you've ever set up a 401k or something. We have like risky and less risky portfolios. And then how do you handle how much you have in either at the same time? So this you can also set up for having an agent or reinforcement learning help with that. And then kind of tie all these things together, basically doing trading, dynamic hedging, dynamic asset allocation, where maybe you're buying bonds instead of stocks, which is pretty interesting. And then almost the last chapter was optimal execution. This talks about a little bit more about the model implementation, the execution environment, different types of agents that you can include, and then kind of how to execute those really large trades with minimal impact on the market. So a lot of the optimal execution wasn't about, like, when I think of optimizing a model, it's like how to make it run faster on infrastructure. A lot of this is actually like if you're going to do really, really massive trades, which would be way more money than I would ever have, I'm sure, in the market. But if you're doing that as a big financial firm, you have to think about how to do this over time so that if you sell off all of one stock, it doesn't plummet the price, or if you buy it all at one time, et cetera. So like there's strategies, or yeah, you can make it rise and fall really fast. You don't always want that to happen. So there's execution strategies to make sure that you actually don't affect the market negatively towards you, kind of as you're selling these off or buying them a lot. Which again, very interesting. I never really thought about that, but totally makes sense. And hey, Walter, how's it going? It was fun to see you at ODC East. I am not sure I'll be able to make it to ODC West this year, but potentially. But it was really fun to see you in person at ODC East because we had talked so much, I think, at AI book clubs and other meetups. It was really cool to run into you in person. And then chapter 10 was concluding remarks. They just talked about kind of the limitations of the simple models environments. Like I mentioned in the book, they're pretty simple. In real life, the markets are very, very complex, and there's a whole bunch of ML or RL research, actually, they mentioned, that is often simplified because they're doing studies on it, making sure something works in like a paper. When you bring it into the real world, obviously it might not work as well as like kind of the research suggests with some of the papers. You want to be aware of the limitations and then try out kind of all the stuff that you saw in the book with your own data. And curious if anyone else actually read the book. If you had any comments on it, anything interesting to add. I thought it was interesting to, like I said, for me, read more about a vertical that I don't always work in, or I don't really work in, which is like the finance piece. it was fun just kind of thinking about stuff that I hadn't really thought about before. Like I mentioned too, I might cut the stream a little short today because I had something pop up, unfortunately. Usually we go for an hour, but if the chat is also just kind of quiet today, maybe it kind of works out in my favor that it'll be a little bit of a shorter, a little bit of a smaller book club this month. People might not be as interested in the vertical aspect, actually, like the for finance piece, which is interesting. This is the first time we've actually read a book kind of with a vertical aspect. So maybe we'll replace the biology one, which was slated for November, but I haven't posted the event yet. Maybe we'll post this or replace this with the agent one if it actually comes out in October, which it's slated for. So maybe I won't post this one yet. We'll leave November open. And I get if people aren't as interested in specific verticals like finance or biology. It makes sense. It's not where you're working in. And maybe I'll leave this a little bit more open for generic ones. Like, I mean, agents right now is obviously what everyone's learning about and building. A lot of people seem to like that content. Ram said they didn't have time to read this book ahead of time. It's interesting to see domain-specific considerations and approaches. Right. So you're interested in it. Yeah, I don't know. I mean, I'm kind of interested in it as well. The biology one I think sounds really cool. I've always thought like working in that space could be pretty fun. But again, I haven't done like I think it has like protein folding. Oh, well, I see Cody's here. Sorry, Cody, I missed you coming up.
Hey, what's up, Sage?
How's it going?
Good. Yeah, I was definitely excited to hear where people were coming from with their interest in finance, because it just seems like, finance as an area can be very broad. Like my particular interest is in algorithmic trading.
Mm-hmm. Have you done a lot with it?
Yeah, I've been kind of programmatically defining this one strategy, which is kind of like essentially a breakout and retest strategy. And the thinking behind the strategy is you establish some key levels. So you can look to like the previous day's high and low. And then you can also look at maybe the opening 5-minute range. And so once you've marked off like the highs and lows for those two ranges, you're looking at a total of 4 key levels. You're kind of looking for price to break out of that range, but then to retrace and test that key level. And the thinking is if it then rejects that key level and you see a continuation of that original move, then you can feel kind of like high confidence that it's a real move. And that's where you can enter the trade. And then at that point, it's all about your risk management decisions, making sure that you're targeting R value that's going to make it so that you can be wrong just as often as you're right and still make money. So yeah, it's been interesting. It's finally trading live money now on Interactive Brokers, and
that's just what I was going to ask. That's awesome.
yeah, it's up 10% this last month, which is great. But then again, the S&P was also up 10%. So
right.
just. But I guess one thing I'm really wondering is when you think about like creating a strategy and defining a strategy, it seems like from some of the books that I've read from algorithmic traders, everyone is kind of suggesting the same advice, which is to make sure that your strategy is rooted in psychology, which is to say that there's a coherent sort of psychologically grounded story that you're telling about individual behavior, right? So like in my example, it's like the whole reason why that key level breakout and retest might work is that a lot of people are watching those key levels. So there's like a shared psychological understanding there. And everyone cautions against just letting your machine learning models kind of discover which features or which indicators it's going to pay attention to. But I'm starting to just wonder if, like you mentioned AlphaGo a second ago, like it wouldn't have been anywhere near as successful if it was only making decisions off of, established heuristics that the engineers coded up into its system. Like instead, it was able to try any number of things, right? And like what we see in like Move 37, all of the experts were like, "What?" It's like that's so left field. It's like, what is it even thinking? I don't know. But it was successful, and so I just wonder if, like, with AI just becoming more and more powerful and capable, if maybe that classic advice is starting to break down, and maybe it's time to be open to kind of starting to trade some algorithmic strategies that aren't even really understandable in human psychological terms, but are more just like a strictly like signal, more in the underlying math.
Yeah, I wonder if that's so right now, just is that like a risk that people just aren't willing to take right now with money? Because I guess it's like with, obviously it's like you don't always want to do that in domains like healthcare, for instance, where you're like, well, if and then you have liability of like if you're like a healthcare professional, you're like, well, AI just told me to do this thing, and like uh, maybe it was right, and you always have to have like kind of a lineage or something where you can go back and maybe even debug like why it said that thing. And I don't work in the finance industry, but is it like when you're doing massive trades, is it too risky versus like we can do this psychology strategy and get a reward? But I kind of agree with you. Like if this is getting really good, and if you do it, if you're building models and evaluating them, even if you're not trading real money yet with them, I would think you'd want to look at those features and then maybe experiment more with them, right?
Yeah, I think you make a great point. If you're trading other people's money, like if something goes wrong and they come to you and the best story you have to tell them is like, oh, the machine told us to do it,
Yeah.
then that's not a great look.
Yeah, and I know in some financial industries you basically have maybe not for algorithmic trading, but for example, I think in like credit cards and that type of stuff. Like if you have a card not approved, someone, I think often you need to have a reason why, and it can't be that a black box model told you that. So like there's interpretable models that are simpler, and you can actually see the features that got aggregated together why, and then why you got that prediction out. So yeah, I am curious. I don't know how that works when you're trading other people's money, or like what that looks like. I have no idea kind of laws around it or what the norms are. But I would imagine that with the big firms, like you said, even if you are not actually trading money, it seems like you would want to be building these models and then seeing how they would have performed historically, and then maybe taking the things that it found and bringing that potentially in.
Yeah. Yeah, and I guess on that point, the other question I had written down is related to the historical testing, because like when you look at back testing, like let's say you've got an idea and okay, you've defined it algorithmically, and now you're ready to test that idea. Naively, you might take your entire, whatever it is, a 10-year collection of time series data, and you might test on the entire thing to kind of tune the parameterization of your model. But that is just running straight into this overfitting problem. And if you're just optimizing on what's happened in the past, you might really be training on those quirks, really, and basically you're fitting the noise instead of the signal. So people talk about this like walk forward idea, but I don't know. It's like I haven't read this book, so I wanted to kind of ask you. I'm really still trying to understand this walk forward backtesting idea. Like, let's say that if you have 10 years of data available, it sounds like the idea is sort of like you'll train on the first year and then test on the next 6-month segment, and that way you're testing on data that hasn't been seen before, so there's no leakage there.
Yep.
But then eventually it's like you want to kind of keep training. So I'm not really sure what it buys you that you can like kind of peek into the progress almost and test as you go. I'm really still trying to build intuition around that.
Yeah, it seems like it's just like you said, or kind of like you said. Like actually, what was the and I'd have to maybe revisit what was the chapter where it talks about um, like you have like just like you said too, you don't want to have data leakage, so you usually do have like a cutoff in time series data. So you're looking at whatever year, months, or something like that, and then you see how it does predicting. I think from there, you're kind of, I guess with RL it's a little different too, but from there it's like you're learning what features to pick up on, and then you can test, then you can give it more data and see if it learns more about those right features, and then makes a better prediction for the year after. But I guess what you're saying is, why not just give it all that data in the first place and then do a prediction on the last year out of, if you had 5 years or something like that, instead of just walking
Yeah,
forward.
that is kind of what I'm saying. But
Yeah.
even though I have seen what it looks like when it's, like if you look at the historical performance and it's like insanely good,
Mm-hmm.
and there's part of your brain that's telling you like, oh, this is too good to be true.
Yeah.
It's then it probably is,
Yeah.
and you
Yeah.
roll it into production and sure enough, it kind of fails.
I kind of feel like, this is my hunch, like I haven't done this yet either, so maybe it is just like kind of for evaluation, like being able to chunk it up and evaluate how the model's doing before it sees all of it. And cool, I gave it 1 year of data, and the next year it did really good, and then the next year it did really bad. Like, was it just because like the second year was so close to what the first year looked like, and then the third year is very different, and then I guess that gives you kind of some chunks to understand maybe like what it's looking at. That's kind of how I would think about it, I think. And I've
Yeah.
done some of the look at it like with other time series data, not in reinforcement learning like this, and it can be helpful to see why it made the decisions it did. And then so like if you have it chunked up and you have like an evaluation platform or you're just inspecting the data or whatever, you can clearly go, oh, I get why it did so good for the first 2 years and the third year really didn't do good. And then also maybe there's some stuff that you can then add in. Like if you're using synthetic data, like in some of the chapters it talks about, you might be able to inject in noise that you saw like wasn't in the third year or something like that. And that's why it did so bad.
Right. Yeah, and there are different market regimes too. Like if
Yeah.
you're looking at the past 5 years, even it's like a strategy in 2021 when everything in the market was seeing like frothy bull market, it might perform very different than in 2023 when it
Yeah.
was all unwinding and we were
Yeah.
seeing the liquidity go back out to
Yeah.
sea.
Yeah. And then like it mentions too, like predicting a giant stock market meltdown is really hard. Like, and that might happen in a year or two, and then you can kind of see how it performed in that year versus last year, or maybe then you take out that data or something like that, right? Or clean that data up and somehow. So I assume you'd want to keep that data most of the time, but you might be able to flag it somehow and be like, this isn't normal.
Yeah, that's actually really true. Like I know how, you know, Tesla uses synthetic data to train on edge case scenarios that they couldn't reliably see
Yep.
in the real world. Like, a lion crosses the interstate.
Yep.
Like it seems like you could do the same thing in this world of finance, where it's like you look at what happened in Black Friday when it's like, okay, the whole market bleeds like 10 to 20% in a single day. It's like you could throw that scenario at it and, sort of like to try to create some guardrails for worst case scenarios.
Yeah, if you had like features that you think, oh, now that I'm looking at the historical data, I can actually kind of see these features that, or maybe the model sees them, you don't even see them yet or something. But if it can pick up on features that could indicate to it historically, that could be really good.
Yeah, which is super interesting because like the GAN thing that you referenced, it's like I'm not super familiar with that, but just the A standing for adversarial, it just makes me think of like that kind of game theory sort of thinking where you are trying to probe for weak spots. So
Yeah, with the GAN specifically, the adversarial network is actually part of basically how the network works is you have a generator, which is the G in there, and then you have an adversarial network, and they create an image together. So they basically have one that starts with like noise, and then the adversarial part is actually kind of trained on what it's supposed to be generating, and it says like that noise doesn't look close to what I'm looking for or anything, and it keeps adjusting parameters until it creates an image of a cat that looks close enough or something like that. So that's where the adversarial part is actually just the generation piece, not adversarial in terms of like looking at market data in this case.
yeah. Okay, cool.
But yeah, yeah, very interesting. And I think synthetic data stuff is such an interesting field too. And even for simple cases, like I worked, again, going back to a computer vision example, but with customers that would have like computer vision looking at conveyor belts, and they don't want to look at product, and they want to detect defects, but they actually don't want to make defective products. So sometimes getting that data is really hard. So sometimes you can create synthetic data, like if you have pictures of a broken product, you can basically Photoshop that into images on the conveyor belt, basically, and stuff like that, and actually have it still learn those patterns, but without having to like break more of the product.
Right. Yeah, that's so interesting because like with the robotics use case in particular, it's like if you were to do pure reinforcement learning on the real world outcomes, then it seems like you're really limited in how quickly you can go because each trial takes like
Yeah.
whatever, 30
Yeah.
seconds versus like if you can simulate that data, like let's say you're trying to train a piece picking robot for some supply chain robotics, then you could go way faster.
Yep. Yep. Yeah. And you can take like a beginning of like some real world data and then augment it in a simulation. Like now people are capturing movements of humans and then transposing that basically onto a humanoid, but you can have a layer inside where you have it in like walking in rougher environment or something like that. How would it handle it? And then it can learn to do that. And then you put it into like a humanoid. Or like you had the example of self-driving cars, a great example. You probably don't have that, hopefully, that many instances of the car crashing in your actual self-driving car data. But you can use synthetic data to make a lot of that type of stuff happen, and then correct behavior, how to behave up to that point, basically, like how to avoid that crash.
Yeah, very cool.
I
Okay.
saw.
Well, yeah,
Oh yeah, go ahead.
those are the questions I had written down. But yeah, I guess quickly, as long as I'm on stage, I might as well say, since you called it out earlier, I am fully open for work, looking for work.
Awesome.
I actually moved to San Francisco just because I was so excited by this AI wave. But it's like I'm still just kind of open for what's next. So we'll see.
If anyone's hiring, go check out Cody's profile. And you're in San Francisco. That's great. I mean, got to be a lot of opportunities down there. What kind of job are you kind of looking for?
So I'm coming from a support direction, and I think for this next role, what I've been thinking is like a program manager type role might be really good.
Cool.
Fundamentally, I know I'm like a product guy. That's just how I think. So it's like I want to go in a product management direction. But yeah, I'm open to a lot of different sort of possibilities.
Cool. And I think there's some questions in the chat, but I also mentioned before, I was going to bring up, well, we're hiring at the company I work at. I'll share the link with you. Also share it in the chat. Let me find your profile real quick. I don't know if you want to go back in support role, but I think we have some support roles open even.
Oh, 100%. Yeah.
For some reason, I can't see your profile right now, but if you go to union.ai, I'll find you after we end the stream too, and I'll send it to you. But go to union.ai/careers. We're actually hiring several roles. I think quite a few roles right now, and I think more is going to be added there soon. We're working in the AI space, like AI infrastructure space. We actually just launched a version 2 of our open source orchestration platform that a lot of people use called Flight. If anyone's heard of Flight before, and you missed the announcement today, go check out our version 2 of the SDK. You'll be seeing a lot more of this, I'm sure, in the future, hopefully. But go check it out. Give us a GitHub star on version 2. And then just catching up on some of the other comments in chat. People said some of us are interested in the finance application. Thanks for the book recap. Okay, good to know. And then, so it's a nice aspect of seeing domain-specific implementations is that many of the trade-offs, considerations, and techniques can be cross-applied to other domains. That's very true. That's one reason I like it too. I just was wondering if when people see a domain thing, they're like, well, I'm not interested in finance or I'm not interested in biology, and kind of are less likely to come in. But as long as people are pretty happy with it, I'd still be down to read that biology one in November. I think I would find that interesting. Someone said, are you familiar with a handful of companies that have developed agentic platforms for financial analysis? I haven't looked at any specific agent platforms, but if you have any, share them in the chat. I would be interested in taking a look at them. I know they're out there. I just don't know any names off the top of my head. And then someone said GAN is a precursor to the diffusion models. Yep, GANs were all the rage when I was kind of getting started in deep learning. And then now diffusion models are the cool ones. But you never know, GANs might make a comeback. Someone said, I'm not quite sure what, oh, I think they shared a link to something. I can't tell if that's an event or a job. Patient, I'm not sure what that is, but there's a link in the chat to something. Oh, try it. Something about ChatGPT, 24-month cancer clinical trials. Sounds like maybe an interesting article I'll have to look at later. With that, I think, we're only 9 minutes to go, but I'll probably go ahead and wrap up the stream. Like I mentioned, I have to get to some stuff for work. And this is great, though. Cody, thank you so much for coming up. It makes it way more fun when another person gets up here and has questions and comments on stuff. So, and usually someone does, but this is, thank you so much for being up here.
Absolutely. Yeah. Super stoked for this next month too, building agentic AI systems. I'll actually pick up the book for that one.
Yeah, I think it'll be good. I haven't read it yet, so it sounds good. And I had seen a lot of people saying it was good, like on LinkedIn. I don't know if they were just saying that, but a lot of people were like, this is kind of, I think, the newest agent book, because there wasn't that many until recently. They're all starting to actually come out. It's all been in blogs and papers, and now books are finally coming out. And I know there's going to be a whole bunch in 2026. Like if I look at the O'Reilly kind of early release list right now, so many stuff on agents. So we'll probably have a lot of really cool agent content coming out. All right. Thank you, everyone. Thank you, everyone, also talking in the chat. It's way more fun when you're all asking questions in the chat as well. This is cool. I really enjoyed the book. I've enjoyed every single book so far. Obviously, I have my favorites. I think building LLMs in production, AI engineering, and then the one we read in December, which was building an LLM from scratch. Those, I think, are my top 3 right now, but I've enjoyed every book so far. So if you have book recommendations as well, let me know, and I'll share this link one more time in the chat. If you want to join the Slack channel and talk about what book to read or about the book as we're reading it, you can do in the AI Reading Club channel. With that, I'll wrap up the stream. Again, thank you, Cody. I'll share the link with you later if you don't already have it, and I'm sure I'll talk to you later. Bye, everyone.